let's move on to next term. It's a tube of flow. Tube of flow. Tube of flow is really nothing other than selecting several streamlines within a fluid flow. If these are several streamlines within the fluid flow, a bundle of streamlines selected within a fluid flow with specific within some defined limits is called tube of flow. So streamlines does not enter or exit through this curved boundary of the tube of flow, but only through this ends. Write down subtopic tube of flow. Under that, a tube of flow is a tubular region. Of a flowing fluid, whose boundaries are defined by a set of streamlines. Next thing we have to learn about is the equation of continuity. Now let's see what is called the equation of continuity. If we select two boundaries within a fluid flow, here say the cross-section area A1, here cross-section area A2, if some volume of fluid V dot enters through this boundary within 1 second, same amount of fluid volume V dot should exit from the other end if the fluid is incompressible. So if the entering velocity is V1 and existing velocity is V2, V dot should be equal to A1 V1 as well as A2 V2. This is called the equation of continuity. This is called the equation of continuity. A1 V1 equals A2 V2. And that is the equation of continuity. Okay, now before going into the Bernoulli's equation, we should recognize the pressure of a fluid is the energy per unit volume. Pressure is also a kind of mechanical energy content of a fluid per unit volume. Because we can understand that, see, the units of pressure, Pascal or newtons per square meter, is as same as the units of energy, Newton meter, divided by units of volume, cubic meter. If we look at dimensions of pressure, is also is equal to the dimensions of energy divided by dimensions of volume. Therefore, we can realize that pressure is nothing other than energy divided by volume of the fluid. Pressure also represents a kind of mechanical energy. This relationship leads us pressure into volume is a kind of mechanical energy called pressure energy. The type of mechanical energy called pressure energy also has been taken into account in Bernoulli's principle. Please write this down. And then, if we look at Bernoulli's principle, now we can go into Bernoulli's principle. Bernoulli's principle states that it is nothing other than energy conservation. The sum of pressure energy, kinetic energy, and potential energy of a fluid flow remain unchanged. That is mechanical energy conservation. However, this is subject to some conditions. The flow should be streamlined flow. Steady. Should be the frictional force within the fluid particle, which are called viscous friction forces or viscous forces, should be negligibly small. Such a fluid is called non-viscous or inviscid fluid. Fluid should be inviscid and incompressible. So Bernoulli's equation is valid only for a steady streamline flow of inviscid incompressible fluid along a streamline. If I divide this whole equation by volume, I divide all the terms by volume. Yes, division of all the terms by volume lead me to pressure plus we cancels out here. Mass per volume. Mass divided by volume is density. Here also mass divided by volume is density. This is instead of K dash divided by volume, give me a different constant. This is called Bernoulli's equation. This is called the Bernoulli's equation. Write down subtopic Bernoulli's principle. Bernoulli's principle. Then write down Bernoulli's principle. Bernoulli's principle states that along a streamline of steady streamline flow of a inviscid incompressible fluid remain unchanged. Sorry, Bernoulli's principle states that along a streamline of steady streamline flow of inviscid incompressible fluid, the sum of the mechanical energies remain unchanged. The sum of the mechanical energies remain unchanged. Sum of the mechanical energies remain unchanged. Now write down Bernoulli's equation. This is pressure energy. This is kinetic energy. This is potential energy. So Bernoulli's principle states that sum of the mechanical energies remain unchanged. So we can write that pressure energy plus kinetic energy plus potential energy. Those are the types of mechanical energy of a flowing fluid particle equals a constant. Dividing by volume all the terms, we get a different constant here with different terms. This is the popular form of Bernoulli's equation. Please write this down. So that is the end of fluid dynamics topic, and also this is the end of the unit mechanics. However, before going to the next unit or next topics, we should solve problems based on Bernoulli's equation and be familiar with applications of this principle.